All right, what's up, everybody? We're going to do number 31. This question's cool. I do think there's two answers. It's pretty wild. I don't think I would put one this difficult on the exam, but you never know. Sometimes you guys start to frustrate me. If you think back to, thank you, Mr. Crow. If you think back to the beginning of our vector experience, remember that vectors have magnitude and direction. And if you and I were pulling in complete opposite directions and we were both pulling at 50 pounds, the sum would be 0. Nothing would be happening. The rope would be feeling all of the force. There would be no force moving in any direction. So what I'm going to do is set up, I'll just pick 50 here. Since the 50 and the 40-pound weight combined to give us 48, you know that the angle between these vectors has to be acute. Okay? Now, the reason why I think there's two answers for this question is that remember that vectors do not have position. So when we add vectors, we're supposed to put the base of our new vector on the tip of the other one. And then what that does is lead you to the sum vector. So this green one is 68, okay? So what I'm going to do is go back and I'm going to redraw. Boo. All right, no undo, so I'm going to leave it, Ben. I'm going to redraw this parallelogram. Now, we can find this angle x right there using the law of cosines. Okay, let's call this, well, hold on. Let me just write it down. A squared equals b squared plus c squared minus 2bc cosine of capital A. So we know all the little letters. Okay, so we'll erase this A, and I'm going to call it an X, Ben, because that's really what we're talking about. Just remember that 68 has to be here by itself because it's always across. It's across from its same letter. Okay? All right, so 68 squared equals 50 squared plus 40 squared minus 2 times 50 times 40 times cosine of x. Geez. I guess we'll just start cleaning stuff up. I would like to, here's what I'm going to write. Watch this, Ben. It's how I would actually do it if this was my problem. 68 squared minus 50 squared minus 40 squared. Now those are gone. See how I did that? I moved these to the other side by subtracting them. I'm also running out of room.
Yeah.
Okay, and then we're going to divide by negative 2 times 50 times 40. And that's going to give us the cosine of x. Okay? So then, let me pause this. So we pulled up our graphing calculator, and I lost a couple things. But how do you get rid of cosine, Ben, to solve for x?
Cosine of the negative.
Yeah, good. It's called cosine inverse or arc cosine, but that's good. As long as you know what, when you're trying to find an angle, you hit the blue button, okay? So here's what we're going to do. Second cosine, and then hit your alpha y equals enter, and let's get a fraction. Now we can just type this stuff in one time. So 68 squared, here we go again. 68 squared, and then minus 50 squared. This is so frustrating on here. And then minus 40 squared. And then all over negative 2 times 50 times 40. There you go. Okay. I'm glad that was obtuse because we expected it to be obtuse. Now, I don't have time to redraw this whole thing, so I'm just going to go one color. This angle is 97.5. I think that's a good answer for this question. But the answer that's in the answer key is this one. So you know how to find that?
You would do.
Those are same side interior angles, and they're always supplementary. So I think 82.5 is probably the answer you'll see on the answer. Okay? All right. Boom.